This video is on momentum in 2 dimensions. Question 1. A 4 kilogram block is moving east at 5 meters per second on a frictionless horizontal surface. It collides with a 6 kilogram object initially at rest. The 4 kilogram block then moves northeast at 3 meters per second at an angle of 30 degrees above the horizontal. Use a pencil. Draw an initial and final figure. So initially object 1 is moving to the right at 5 meters per second, object 2 is at rest. Finally, we have something that looks like this. Now the law of conservation of momentum says that the total momentum horizontally initially equals the total momentum horizontally at the end. So if the total momentum in the beginning is to the right, then the total momentum at the end is going to be to the right, meaning we add up the momentum of both masses. And the total momentum vertically initially is going to be equal to the total momentum vertically finally. So if the initial momentum vertically is 0, because these objects are not moving up or down, then the total momentum of both of these objects is going to be 0. So if one object is going to move up at the end, then the other object has to move down to cancel that. So we got positive vertical for one object and negative vertical momentum for the other. You cannot have both of the objects moving upwards. So part B, use the law of conservation of momentum for each axis to determine the final speed and direction of the 6 kilogram block. So here, I'm saying the horizontal momentum in the beginning equals the horizontal momentum in the end. So in the beginning I have 2 objects, in the end I have 2 objects. P equals mv. So I plug in the values for everything I have. And remember, velocity is a vector, so we're going to have a cosine component. That's why I have a 3 cosine 30 here and a v final cosine theta. So I rearrange and I get v2 final times cosine of theta is equal to this. So I have one equation and 2 unknowns. My 2 unknowns are theta and v2 final. Now I'm going to, that was the horizontal motion. So now I'm going to do the same thing with vertical motion. P1 initial equals P1 final. Sorry, P initial y equals P final y. Initially, there was no vertical momentum, so the left-hand side is equal to 0, because the sine of 0 is 0. At the end, I'm going to have m1 v1 sine theta final plus m2 v2 sine theta final. So now I have this equation here. So now I'm going to divide these 2 yellow equations here. So I'm going to get this over this. So the left-hand side is tangent of theta. The right-hand side is actually a numerical value. Solving for theta, I get 32 degrees. And I'm going to use substitution. Substitute back into one of the yellow equations. I get v2 final is 1.89 meters per second. Is momentum conserved? Yes. What's the original total kinetic energy? It's 1/2 m1 v1 squared plus 1/2 m2 v2 squared, 50 joules. What's the final total kinetic energy? It's 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Is kinetic energy conserved? No, because initial kinetic energy does not equal final kinetic energy. Is this an elastic or inelastic collision? It's inelastic, since kinetic energy is not conserved. And is total energy conserved? Yes, because we have the law of conservation of energy. It's always conserved. Question 2. A mass m1 equals 6.4 kilograms is moving towards the left with a velocity of 11.2 meters per second when it collides with the second mass, 4.6 kilograms, which is initially at rest. After the collision, the first mass bounces off to the right of the initial path of motion with a velocity of 9.5 meters per second at an angle 20.4 degrees north of west, while the second mass M2 bounces off to the left of the original path of motion with a velocity at an angle beta. So part A, draw initial and final figures. So I'm going to let positive x be to the left to minimize my positives and negatives. And this is what I got here. M1 is moving west. M2 is at rest initially. And finally, M1 is going to move somewhere to the northwest, and M2 is going to move somewhere to the southwest. So part B, use the law of conservation of momentum for each axis to determine the final speed and direction of the 4.2 kilogram block. So first, use the law of conservation of momentum in the horizontal direction. In the beginning, we have two objects. In the end, we have two objects. We know P equals mv. Substituting our values. Now we get one equation with two unknowns, and I highlighted it in yellow. Now I'm going to use the law of conservation of momentum in the vertical direction. I know there were two objects in the beginning, two objects in the end. I know P equals mv. I substituted for everything that I know, and now I get this equation. So now I'm going to divide the two yellow equations. And then I end up getting theta equals tangent inverse of 1.44237, which is about 55.3 degrees. And then I could substitute back into one of the original yellow equations to solve for V2 final. Question 3. A mass M1 equals 6.2 kilograms is moving north with a velocity of 13.5 degrees. Sorry, with a velocity of 13.5 meters per second. When it collides perpendicularly with another mass, 4.4 kilograms moving east with a velocity of 8.80 meters per second. M1 runs into M2 in an inelastic collision, and both masses stick together and move off after the collision with a mass M final at an angle theta final. Determine the final magnitude and direction of mass final. So I'm going to let positive x be to the right, positive y be up. So you could see what I did here. In the beginning, I have two objects. And in the end, I have one object. And I use a law of conservation of momentum. And here, I'm just using the horizontal here I'm using the horizontal direction. And then here, I'm using the vertical direction. And then I have two equations, two unknowns. I'm going to divide the two. Then I could solve for theta. And after I solve for theta, I could substitute back into one of the original yellow equations to solve for V final.